Hello students, let's continue with our lesson. So today we are going to start with impact of jet on a moving flat surfaces, meaning what will happen if a jet strikes a moving plate. So the moving plate, the plate may be moving in the same direction as that of the jet, or it might be moving opposite to the direction of the jet. So for both the conditions, let's understand how shall we go about with the analysis. So first thing, let's understand that the velocity with which the jet strikes a moving plate is the relative velocity of the jet with respect to the plate. Now, what is relative velocity? Mathematically, the relative velocity is the velocity of jet minus the velocity of the plate. So there are two conditions. Plate is moving in the same direction of the to the jet, or the plate is moving in opposite direction to that of the jet. So in first condition, the relative velocity of jet with respect to velocity of plate is given by velocity of jet, that is the absolute velocity of jet, minus the velocity of the plate, whatever the velocity of the plate here is. So in this example, it's 10 minus 2, that is the relative velocity of the jet with respect to plate. In next condition, the plate is moving in opposite direction. So here the relative velocity is given by the relative velocity of the jet minus, now here one more minus is required because this plate is moving in opposite direction, right? In this direction we always consider negative. So here the direction of this plate is in negative direction. So minus the velocity of the plate. So here it's going to be velocity of jet plus velocity of the plate. So that is what you need to understand to solve a problem relating when the jet is impinging on a plate, uh, when the plate is also in motion, okay? Either it is in the same direction or it is in the opposite direction. So to understand better, we also have to revise our uh, concept on vector additions, okay? The triangular law of vector addition. Let's start with triangular law of vector addition. So what we do is, if there are two vectors, okay, let's say v1 and v2, and v1 is inclined at some angle, okay, so to find the resultant vector, I'm not talking about relative, I'm talking about resultant vector. How do we do is, first you draw the vector 1 in magnitude in the same magnitude and in the same direction, okay, where magnitude represents the length, and you draw vector 2 from the tip, and the vector that joins the base of vector 1 and the tip of vector 2 is the resultant velocity. Likewise, let's also talk about relative velocity. Relative velocity is subtracting, right? We are subtracting two velocities. So vector 1 minus vector 2. So instead, here we say it's a resultant. Here we will say it is relative velocity of 1 with respect to relative velocity of 2. Or this can be somehow modified in this setup. For in a vector analysis, the sign is nothing but it is the direction of a vector. Sign indicates the direction. So vector 1 minus vector 2 is as good as saying vector 1 plus vector 2 in opposite direction, right? So we use the same analogy like we have discussed. You draw vector 1, and from the tip you draw vector 2 in opposite direction. So here, from the base of this vector 1 to the tip of this vector 2 is the relative velocity of 1 with respect to the velocity of 2. So this concept is very important in upcoming session, okay? Next is, let's understand in detail of the how to calculate the relative velocity in one dimensional and in two dimensional. So let's take an example of one dimension. One dimension, why I'm saying one dimension is the vector 1 and vector 2 are not inclined with each other, okay? There is no angle between vector 1 and vector 2, but there is some direction. So it could be either in same direction or in opposite direction. So in same direction, the relative velocity of vector 1 with respect to the velocity of 2, I want to find the relative velocity of vector 1 with respect to velocity of vector 2. So how do you do is, you draw the vector 1, then from the tip you go in reverse direction. So because you are going to subtract it, right? So the vector 1 2 is nothing. This vector 1 2 is the relative velocity 1 with respect to velocity of 2 is represented as 1 2 is vector 1, right? Vector 1 minus vector 2. So this is the magnitude. Okay, this is the magnitude of vector, relative vector, relative velocity or a vector of 1 with respect to 2. So this is the magnitude, and direction is whichever is greater, the direction will dominate, right? We know this. All right, so in next case, this is the second case where the velocity 1 and velocity 2, vectors 2, okay, vector 1 and vector 2 are in opposite direction. So to find the relative velocity of vector 1 with respect to vector 2, what we do is we draw the vector 1, and from the tip we change the direction of vector 2, and then we find the this. Now from the base of vector 1 to the tip of vector 2 is the uh, relative velocity of 1 with respect to 2. Mathematically, it is vector 1 2 is equal to vector 1 minus, again minus vector 2, because this is in opposite direction. So that's why it becomes plus. So is also is seen in the graphical form. The magnitude has enlarged now. See, in two-dimensional, let's say, sorry, in two-dimensional, sorry about that. So in two-dimensional, there's vector A, and let's say there's vector 2 in this orientation. So it has some inclination with respect to vector 2. So velocity of A with respect to velocity of B is nothing but the relative velocity of A with respect to B, right? So to find this, what we do is first you draw vector 1, and from the tip you reverse the direction and join the base of vector A to tip of vector B, and that would give us the relative velocity of A with respect to B. Now, if we join this base and the tip, it forms a parallelogram, right? So you can see this. So in either way, so this is one method. Another method is you can simply keep same direction, okay, same magnitude of VB, but join from the base, and from tip to vector B to tip to vector A gives the relative velocity. So this method is explored in our upcoming session. Okay, please understand the difference. If you join this dotted line, it forms a perfect parallelogram. So this is also valid. So either way, it is one and the same thing. So please understand this, how these things are constructed. I believe it is already taught to you guys in your engineering mechanics and the physics classes, but still it is good to revise it once, because we will be using this in our upcoming session. Okay, with this, let's solve a problem. The problem is a jet strikes a moving plate at velocity v jet. Velocity of jet is 10 meters per second, as the plate moves at a velocity of u is equal to 2 meters per second, as shown in the figure. Determine the force needed to hold the plate in its place. What would be the force if u is reversed? So there are two conditions. First one, we need to calculate the force. Next one, we also need to calculate force when the direction of this plate is reversed. So to analyze this, first we start by constructing a control surface or control volume. So this is control volume. Be reminded that this control volume is moving along with this plate. Okay, so once the jet strikes, this control volume is also moving. So this moving control volume is what we are analyzing. So let's take this control volume and let's represent the vectors. That is the velocity that is coming in, and which is the relative velocity of jet with respect to the plate, which is, because these are going in the same direction, so it becomes v minus u, where v is the velocity of jet, u is the velocity of the plate. And these two vectors are the vectors that is going out of the plate, right? Once it strikes, then some portion will go from this side, some portion will go from this side. In two-dimensional, in three-dimensional, it will be going all around, but we are analyzing this in two-dimensional. Okay, so again, one more thing is required, that is the force, right? Because of this force, it is causing the momentum to change. And similarly, we have also studied this, the force is nothing but the momentum flux going out of the system minus momentum flux coming into the system, which is the change in momentum gives the force applied, right? So let's substitute the value. Minus x is because the force is in opposite direction. By the way, this force is the force acting. This is the force. Uh, this is the force that is been, the plate is acting towards the jet. Okay, the force offered by the plate to the jet is minus F. Okay, so the force that would be offered by jet to the plate would be equal in magnitude but in opposite in direction. So going out in x direction, nothing is going out in x direction, so 0 minus what is coming in. So coming in is rho q is nothing but is the mass, right? Mass flow rate times the velocity. So this velocity, this p is momentum, or momentum is mass into velocity. This mass into velocity. Velocity is the relative velocity. Further, let's substitute the value. So one more thing that you need to be careful in this calculation is how you compute q. So 0 minus 1000, right? Density 1000. Now q is area of the jet multiplied by velocity of the jet. But here, one more thing you need to understand is the mass that is actually striking the plate, it's not same as the mass that is coming out of this nozzle, because the plate, as the jet is striking, the plate is also moving, so all the mass is not striking the plate. So that is what we need to understand here. So that's why when you calculate q, you don't take the absolute velocity of the jet, but instead you have to take the relative velocity, because of the fact that as the jet the jet is impinging on the plate, but the plate is also moving. So in the process, all the mass is not striking this plate. That's why we're taking the relative velocity in calculating q. So you substitute the value and finally you get the force. Now, if direction is making you confused, that's why I put the actual direction sign. So f of x, this is the force impinged by the, this is the force in fact offered by the jet to the plate, and this is the force this is offered by the plate on the jet. Okay, so this much force in magnitude it is required to hold this plate in first condition. Now for next condition, so next condition, what will happen is the plate is moving in opposite direction. The relative velocity is v plus u. Okay, everything remains same. So again, we put in this impulse momentum equation here, and only the difference is instead of v minus u, only v plus u. It becomes v plus u, and accordingly we can calculate the force. Okay, so that's it. This was for condition 1. This is for condition 2. Moving on, so this is a homework question for you. You can solve this and then submit later on. Accordingly, this is also a next problem which you can think of. So that's it. Let's end the video here for now, and we'll continue in next video. Thank you.